So when you first open the website, you should see this. It maybe seem a little overwhelming, but when you understand the basics, it's actually quite simple. This is a great example of a supervised learning model, a classification model, to be exact. So over here are the features or the input layer. So we've selected x1, x2, basically meaning the x and y coordinates labeled as features for some reason. So we can ignore all these. These have like no meaning for us now. So hidden layers, there's two hidden layers, 4 neurons in the first hidden layer and 2 neurons in the second hidden layer. And the output layer out basically it visualizes what the machine or the model would output at each x and y coordinate. So we can run it. So we can stop. Okay, each epoch is one full iteration of a forward and backward propagation of batch size 10. Um, each backward propagation minimizes the loss function. So as you can see here, this graph, the loss function drops suddenly, and the model is now doing a pretty good job of predicting well where the blue dots and where the orange dots are going to be. As you can see here, orange dots actually means, or just orange, the orange area is negative while the blue area is positive. As you can see here at the second last or the last hidden layer, it actually learned some relationships that I can use for the final layer. As you can see here, this. Oh, also, you may notice that this is the exact opposite of what we want. So here, the weight is -3. So because it isn't, the weight is negative, the whole thing here is literally flipped. That's why it gives a pretty good output after. As you can see here, on the second to last hidden layer, it has just learned some simple concepts like a simple boundary, simple boundary, simple boundary. But combining all of these, it is able to form this, and by forming this, it is able to finally give out a satisfactory output on the output layer. But if you want to play around more, you can select different data sets. For example, this spiral data set. If you run it again, you'll see it. Even after a lot of training, it still does a pretty bad job of visualizing this data set. But the good thing about a neural networks or deep learning is that if you give it enough neurons or hidden layers, it can do literally anything. Of course, if you give it permissions or just the infrastructure to do it. For example, using this configuration, max hidden layers, max neurons on this website, you can wait for it. As you can see, it is kind of learning how the data makes sense, how it works. As you can see, this is the test data it uses to like test it after it trains it. We can change it to 80%. Start again. Generally, it is 80 to 20% for how to use for test data used, and it is trying its hardest to map out the spiral data set, but of course it isn't easy, and now it is doing a reasonable job. As you can see here, because I'm using the ReLU activation function, it won't output any negative numbers because it literally says if it's below 0 then it is 0, so there's no negative numbers. But since the weights can be negative, it can still show the relationships. As you can see, that last layer, it is now showing some pretty complex shapes for compared to the one before. Now mapping, now for example, this one is basically what the final output is, and this is showing up. We can also change the learning rate, which is basically how far it descends. For example, we can change it to 1. Now it just just does that because since learning rate is 1, it changes so suddenly to every single imperfection, which makes it worse actually. So we can use some other data sets. This one is pretty simple. This one, just neuron, is not even activated at all because it's just useless because this data set is so simple. So this using this many hidden layers and this many neurons is such a waste of time if you're actually doing it professionally, I guess. And this is showing relationships it learned. We can't use this. And it's still pretty simple. And now it is even learning the entire data set on the second hidden layer, which is pretty funny. And now it just learns everything on the last layer.